Let me show you how to do things in R, the things that we discussed in this learning sequence. And let's start with making scatter plots and also how to fit points on the scatter plot with a line, how to compute covariance, correlation, all that kind of things. As usual, I open the folder where I keep all my code and all my data set. I will use people data in this case. I will try to reproduce the one of the slides where I showed you different scatter plots for people data for selection of variable pairs from the people data, and then I'll add correlation and covariance on top of this plot, exactly what you see here now. Okay, I'll set it as a working directory and make a new script. I'll call it somehow like, for example, lecture 3.1. So it's the third block and the first learning sequence here. And first of all, I need to load the data, right? You know already how to do it. Read Excel, we load library read Excel to read the data from Excel file. Then we read the data set from people XLS. People. We run it. So I check that everything is read correctly. So you can see numeric. And then this is not necessary actually, but I used to do that. It's to convert this data to data frame, as I also showed you in some of the previous videos. Let's learn how to make a scatter plot. Let's, for example, let's take height and weight. Let's make a scatter plot for height and weight, right? Well, there are three different ways to make a scatter plot if you have a data frame. The easiest way is just to write b plot and then specify x and y values as vectors. For example, $height, height, and then $weight. That will produce a scatter plot. By the way, it's a very good idea to make scatter plots squared so they have the same height and width, right? The problem here is that, first of all, it uses these names of the variables that you provided as also as access titles, access labels. So you have to change them manually if you want, for example, write in xlab, for example, equal to height or height in centimeters or something like this. Okay. So that's it. However, that's the plot. That's the plot that we need. The second way to do that is to use, for example, names of the columns or number of the columns. So, for example, I know it's a column number 1 and 2, so I can simply write it like this. And I will get the same. And I will get, no, it's not 1 and 2, it's 2 and 3, because 1 is, I'll show you, 1 consists of names, right? You can see it's names. So it's columns 2 and 3. And then you can see I got the same plot. Okay. I can also use names. For example, I can write instead of 2, I can write height as a name of the column. It means in quotes. It should be in quotes in this case. And then also weight as a name of the column. And then you can see it's, let me check quickly. Height, not heights. Yeah, so now it's the same plot, but you can see again the labels, the access labels look weird. Okay. For data frame, there is another way to do that. Well, in these ways, it will work for any two vectors. If you have them separately, like x and y or h and w, it will work. But for data frame, you can also use a formula, like you also did it, for example, for box plot. You simply write plot, then you write your y variable, what you want to have it as a y variable, for example, weight. Then you have tilde, which is a relationship, you remember, and then the height. And then you can say data equal to d, meaning that weight and height are not separate variables from here. They are columns of this data frame d. And then you can see indeed, in this case, first of all, you got the same plot, but also have nice names, which simply corresponds to the names of the columns in your data frame D. Which way to use it's up to you. If for a quick and dirty solution, this is the best way. But if you want to make, for example, a function that will make some advanced plots, that probably this way would be better. But we will consider several ways here. Okay. So that's the first thing. And then since it's a scatter plot, you can change a lot of things. For example, you can change a character, which character to use as a scatter. You can either specify a number from 1 to, as far as I remember, 21 or 25. For example, 1, it's a default number. It's the circles. Then 2 will be the triangles. 3, you can see, will be crosses, and so on and so forth. You can see all the numbers. If you write plot 1, let me check 25, for example, 125, PCH equal to 125. So the meaning of this is following. It will make a plot, diagonal plot. X goes from 1 to 25, Y goes from 1 to 25, and every point will have its own separate character. So that's it. You can see some of these empty, like nothing inside. Some of them have a pattern, and then some of them are filled. So for example, if I write, let me see, 1, 2, 3, 4, 5. If I write 5, I will have these diamonds, right? Then if I specify color, as I said, it will be color of the border. And then you can change, for example, size. It's CEX, parameter is called CEX, and the idea of this parameter, it's a scale. So if it's 1, it's the same size as the original. If it's 2, it's twice larger. If it's 0.5, it's twice smaller. Okay, for example, let's take 1.5, so it's 1.5 times larger. And you can also change the size of the boundaries. You can see LWD, it's a line width. It's a width of these borders. So you can check it, for example, like make it 3 or 4 or 5. And how much you need to set it to, it depends on, of course, on your screen resolution and so on. So that's how it looks like. Now, if I make a new plot, weight and height again, let me just copy and paste probably. I need only this part. So this is a new plot. And now if I check this, you can see that I can actually add a text. 125, 125, 125, and then plus equal to 3, for example. And then you can see maybe 2. Let's check. It's not plus, it's pause. Sorry. Like this. So you can see, let me run it again. I have a text beside each marker. So this is 1, this is 2, this is 3. Because I say show a text, the text label should be this from 1 to 25. This is X coordinate of every label. This is Y coordinate of every label. And this is position. 1 means under, 2 means on the left, 3 means on the top, 4 means on the right. Okay. And then you can see, for example, 16 or 20 or, for example, 18, they are filled, right? So let me take, for example, 15, right? So I can write PCH equal to 15. And now you can see they are filled. And if I write color equal to red, you will see that they are filled inside as well, right? Now if I get back and show you again this plot, you can see that some of these, they kind of resemble this one, but they have different order, right? So let me also add a text. So this 21, 22, 23, 24, 25 is they are in fact different markers. They are different from this one. These markers may have both background and color, different color of background and different color of the border. So let me again show you this. So if I write it like this and then change it, for example, to 21, you can see it looks like the original color, right? But it's not, because now I can also specify background. For example, I can write background equal to, I don't know, green. And now you can see that we have both background and the what is inside, right? What is a fillet color. And I can also, of course, change the thickness. I can change the size, for example, 1.2. And then you can see, you can make any plot you want. It's like a Lego. You assemble anything you want from these small pieces. Okay. So that's it. Now let me show you another important thing. So let me just take this and use, for example, PCH equal to 1 and color equal to red for a while. Right? What if I want to show males and females separate color? So how to make, for example, people who are males blue shown as blue color and people who are females shown as red color? In this case, I need to generate colors for every point. So for example, I need to generate a color which will be every time. Let me show you this $sex. You remember $sex is a biological sex of people that we have in our data set. And then you can see if it's -1, it's male. If it's +1, it's female. My point is, I need to have, every time I have -1, I would like to have blue color. And then every time I have a +1, I would like to have red color. How to do that? Well, the idea is following. You compare sex with one particular value, like -1, right? And then you can see I have truth and false. And what you need to do, you need to tell R, if it's true, it should be blue color. If it's false, it should be red. How to do that? There is a special function, it's called if-else. So it takes all these vectors with truth and false, and then it replaces the value of this vector to the first value if it's true, and to the last value if it's false. Okay, so let me show you how it works. You can see we have blue, 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 and then red, red, red. Again, if it's true, it's blue. If it's false, it's red. Okay. Now I can save it somewhere, for example, to variable color, and then I can use this variable here. I can use this variable here, and then you can see, let me run it first, and then you can see that indeed now we have blue and red, so the blue are males and the red are females. Okay. What is next? I can also do this trick for regions, but in this case, let me generate different point characters. For example, I can write if else $region equal to -1, then it should be, for example, 1. Otherwise, it should be 2, right? And then I will provide this generated PCH as an argument of this function. So first I need to run it. And now you can see that every time you see a triangle, so that's the region equal to +1. So it's a Mediterranean region. Every time you see a circle, it's a Scandinavian region. Okay. You can even add a legend that will show you that. For example, you can say legend. You need to display position top left. It's this corner. Then you specify the labels, or just legend equal to, for example, let's start with simple legend, male and female, right? Male and female, and then you specify color. So we know that male shown as blue, the female shown as red, and also the point character. Let me use a circle for a while, okay? So this is it. You can see male, female. This border can be removed, or you can change it. You can move the legend to any part of the plot, but that's the simplest case. You can see male and female. If you want to make a more complicated, for example, have males from Scandinavia, females from Mediterranean region, let me make some extra lines here in order to fit all the code. And then I can say, okay, male from Scandinavia, female from Scandinavia, then male from Mediterranean region, female from Mediterranean region, and then I simply combine. For the color, it will be blue, red, because I have male, female, right? Like this. For PCH, it will be C, 1, 2, 1, 2, right? Let's check. So let me run all these two lines together. And then you can see, indeed, we have males from Scandinavia. It's a blue circle. Females from, I think I made it should be 1, 1, and 2, 2, of course. Yeah, because Scandinavia, it's 1, and then Mediterranean is 2, right? Let me try again. Here we go. So males from Scandinavian, females from Scandinavian. So circle means Scandinavian, and color means male, female, right? And then male from Mediterranean region, female from Mediterranean region. Again, triangle, the shape means the region, and the color means the gender, the biological sex. Okay. So this is it. Now what else we can do? We can also fit these points with a straight line. In this case, we use AB line that we already used before. Before we used it to show, for example, a vertical line or a horizontal line. But what you can do, you can make a line fit. Function LM, we will learn it also in the next learning sequence. It makes a line fit between two variables. And then for the line fit, you use the same formula and you use the same dataset. So I will simply copy here and paste here. And then you can see that's the line fit. So that's the line that fits these points best. Okay, what is best, we will learn in the next learning sequence. I can, for example, change its color. For example, I can say color equal to gray. And then, for example, the line type equal to 2, it will be dashed line. Now I need to run everything from the scratch because line is added on the plot that is already exists. So I need to make a new plot. And indeed, you can see it's dashed line and it has a gray color. Okay. So this is how to make like a short intro how to make different scatter plots, and then the rest you can actually do more. You can even colorize your points according to a numeric variable. There are many different possibilities. I would recommend you to look into, for example, legend, how to make different legends, and all the other things. Okay. Next thing you can do, is to calculate. Let's learn how to calculate covariance and correlation. Well, that's again relatively easy. You simply write cov for covariance and provide two vectors. So for example, $height, $weight, and that gives you the covariance, right? If you want to compute correlation, you write correlation $height, $weight, And that's compute correlation. So instead, in this case, you can see covariance is 146.6. You can check what we also had in the video, in the learning sequence, on the slides. And then the correlation is 0.96. Okay. And of course, you can make a test. You can make a correlation test, assuming that the population correlation is equal to 0. So you can make a test. You can compute confidence interval. In this case, you simply run a function which is called core.test. And then this is the results. You can see that this is a p-value for null hypothesis that there is no correlation between height and weight in case of population. And this is the confidence interval. And it's also based on this Z prime transformation, exactly as I discussed in my learning sequence. So this is the confidence interval. Okay. So now let's learn how to add these values onto plot. For example, I want to add these values at this position where we have 160 as x and weight as 80. You already know how to add text. I already showed you that, this here, right? So, but now let's learn how to add these statistics, right? So first of all, let me save it. So I use cof like CV, right? Otherwise, I will have troubles if I use cof. So I save these two statistics here. You can see this is the covariance, this is correlation. And now I need to do the following. I write text, right? Then coordinates 160 for x, 80 for y. And then now I need to tell R which text I want to show. For example, if I write R, it will show the correlation. But it shows correlation, you can see that it's like the middle point is here, right? And then correlation kind of spans this part. What I don't like, first of all, it's too many decimals. So let me round this, round to 3 decimals, right? So this is, I need to run it from the scratch again. Like this. Here you go, 0.96. Why not 96 and something? Because this something is 0, that's why it's 0.96. Also, I asked it to use 3 decimals. Now, I also can make it, for example, I can say position equal to 3. And in this case, maybe equal to 4. Let me show you the difference. Let me show you this point, 160, 180. There's just a marker, red marker here. So for example, color equal to red points. Yeah. So you can see, let me again start from the scratch. You can see this is the point where I want to have my text around, right? If I use position 4, it will be on the right part of the point, you can see, right? If I use position 3, it will be on the top. If I use position 2, it will be on the left. If I use position 1, it will be underneath. And then position null, I think it's called, it will be exactly on this point. So the middle point will be there, right? So I will use position 4 here. Okay. So let me try again. So this is it. Let me keep this point for a while, then I will remove it. Now, what if I want to combine several values together? If I want to combine correlation and covariance? In this case, you need to generate this vector with text values first, or just a text value, right? And a glue that takes several values together and make one single text, in R it's called paste. And then you can add any text. For example, you can say AAA, BBB, CCC, and then, for example, 4. And then if you run it, if you write it here, text, txt, right? So you can see this is the text you got, right? So let me again run it from the start. This is the text, right? You can also add a new line character. New line character, it's a \n. In this case, you can see it makes a new line before CCC. So let me try it again. So you can see indeed CCC is from the new line, right? So now let's use this knowledge to make what we want, right? To show what we want. So first we say covariance. And then instead of this, we write the covariance, CV. But we need to round it, for example, to 1 decimal. To 1 decimal, right? Then we make a new line, correlation. And then again, round correlation to 3 decimals, right? So in this case, let's see what we get. We get a pretty nice text. So I forgot equal sign here. So let's try again. So we get exactly the text that we also had in the learning sequence, right? However, you can see that the space between covariance and equal sign and space between equal sign and here, it's doubled, right? Because paste by default adds additional space between all its elements. In order to avoid that, you can write paste 0. It means don't add the additional space, and in this case it will look even nicer. So let me show you that. Now you can see it looks really good. So now we can get rid of this red point, and this is the result. Since it's a text, you can also change its color. For example, you can make it, I don't know, green. You can change it size. It's also this CEX factor. For example, this will make a size doubled, right? What else you can do? You can also make them bold. If you say font equal to 2, it will be bold text. So let me just run it. And indeed, you can see it's large, bold, green text, exactly what I asked it to do, right? Maybe not nice for the plot, but it's just to show you the possibilities, okay? So this is how to compute all these statistics, how to make a correlation test, how to make a scatter plot, and so on. Now let's talk about the correlation metrics. Remember that you can calculate correlation for the whole data frame. This is how to do it. So I write correlation equal to core, but instead of providing the variables, the vectors, I provide the whole data frame. However, you remember the data frame has these names, so I need to remove it first. So I just move it inside, so I say everything but not the first column. That will do the job. So now I can show these correlations, but I will round it to 2 decimals. And this is the correlation matrix. You can see it's too wide to fit my console, so I will make it like this and run it again. And then you can see this is the correlation matrix, exactly what you also seen in my slides. For example, this is the correlation between hair length and all the variables, right? As we discussed, just looking at these numbers is very difficult to see anything, right? So we need to visualize it. And how to visualize it? Well, strictly speaking, you can do a little trick here. You can write image R, and it will make an image where color of every pixel, and you can see pixels are large, right? It's a correlation. So for example, you can see already some patterns here. But it still misses a lot of things. For example, you don't see a legend, what color is what, and so on and so forth. So therefore, I recommend you to install a special package which creates heat maps. Actually, R also had a built-in function for heat map. You can use it as well. So this is the heat map, you can see. And it looks nicer already, right? So you can see it also makes some groupings of these variables. But I usually use a special package. You can use this heat map, which is built into R. It's no problem. But I recommend you to install a package. Let's install it together. Install package. Install package. It's called P heat map. P heat map. I need to make it in quotes. Yeah. So let's install it. Okay, I think I already had installed it. That's why it's too fast. Maybe you will have a little bit longer procedure. Now I load it. Library P heat map. And now I simply write what I wrote before. So I simply say P heat map and then R. And that's it, right? And now you see a picture similar to what you have seen in my slides. You can see, first of all, these clusters, right? So it's automatically cluster the variables. So it makes similar variables that have similar correlation patterns together. It combines them together. It shows the legend. It shows the names, everything that you need, right? What else you can do? You can get rid of these trees. The trees are used for clustering, to cluster the variables. You can actually hide them. In order to hide them, you simply write, for example, you can say, let me see. You can say tree height column equal to 0, I think, right? Let's run it. You can see now this tree disappeared, and then tree height row equal to 0. Now this tree also disappeared, right? And what also you can check, you can change the breaks. So how this gradient is made, right? So you can see by default this is 1, this is minus 0.5, but this is probably not minus 1, right? Because we don't have minus 1 in our data. You can make these breaks manually. You can say breaks equal to sequence, for example, from -1 to +1, and then, for example, 100 values in the sequence, length out 100, and then you can provide these breaks. As far as I know, just write breaks equal to breaks or something. Let's check. Yes, indeed. So now you can see it's from -1 to +1. Okay. So this is actually it about the first learning sequence, how to do things in R related to the content of the first learning sequence. And see you in the next learning sequence where we are going to discuss how to make the linear models.